Hi, it's me, Tim Dodd, the Everyday Astronaut. We just wanted to give you guys a little update here. We're hearing that it's scrubbed, as I know all of you guys are hearing that today's SN15 was scrubbed. But we figured we finally had everything all set up. We wanted to give you guys a little tour of some things that we've been working on and just kind of say hi, let you know that, yes, we are also indeed hearing scrubbed. Since we had everything set up, why not, right? Why not? So let's see here. Let's just do a little bit of a little introduction here. We mentioned this last time, of course, but we do have a second host with us. This is our Capcom, our communications captain, Mary Liz Bender, in studio. Hello.
Reporting for service. Hello. Nice to see everyone today. Hello, Tim.
Yeah, unfortunately, we are looking like a scrub. And poor Ryan.
I know.
For some reason, we had more time than ever to set up. And somehow he got the least sleep.
Yeah. I don't know how it happened, but you know what? We love this stuff. We were just out at the pad. You know, it was no sun whatsoever. Stayed through sunrise. It was absolutely stunning. So we can't complain.
Yeah. But we did want to show you guys a few cool things. Andrew, can we try showing when I do a little rundown on like how big the rocket is and stuff? Is that something we can do? So check this out, because we've been working on, as you guys know, every time we're going live lately, you should be seeing some substantial like updates and cool things that I'm excited about. So check this one out. This is the Starship prototype. It is approximately 50 meters tall. This thing is huge. I always do this rundown. I want to have graphics up on screen. So we do now have some things like this that can help you understand just how big this thing. Take that baby full screen for us. This is the Starship prototype. It is 50 meters tall, about 9 meters wide, so 164 feet tall, about 30 feet wide, or double that with its flaps, so depending on that. Look at that. I believe that is Mary taking a camera. That's when you know it's a scrub, actually. When Mary's taking a camera, yes, it's likely, yeah, very, 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 very likely a scrub. But yeah, we have that. We also have another one that I'm really excited about because we talk about what's on the inside. Our friend Casper Stanley and web crew member made this graphic, which shows where the tanks are and where the different bulkheads are. So we'll be able to do this on screen, on air, every show, and show you guys, where all of the stuff is. Because again, the point of this channel is really to help people that are new to this, is to really get people excited about what all this stuff is. The point of Everyday Astronaut is, of course, bring space down to Earth for everyday people. So in doing so, I want to help explain those, those common questions like, what is this? Why is it important? Why does this matter? All those, those urgent and basic questions. I want to be here to help answer those. So, that's the type of things we're trying to do now is have graphics like this that, there's things that I talk about over and over that are good questions that an average person like, how does this thing work? And we want to be able to point out where the header tanks are and all that stuff. So, yes, it is. We're working on some things here on our end. We've got some awesome cameras here for you guys too as well today. So we would have had, of course, Cactus Cam. Yeah.
Ooh, I love Cactus Cam. Who doesn't love Cactus Cam?
Well, maybe the cactus doesn't love it.
No, I think it loves it. It's finally getting all the attention it deserves. I actually placed this in the wee hours of the morning.
Ooh, what time was that at?
Oh, 5:42, probably.
Oh my, of course, 42. Always 42 with this one. But yes, again, another introduction. We do have, we will have a little name tag thing at some point that says Mary Liz Bender. Of course, she is half of Cosmic Perspective. So Ryan Chilinsky, or Dr. What are we calling him lately?
Dr. Chilsky,
which is not at all how you say his name. Dr. Chilsky, or Mr. Chilsky.
Don't do it.
Don't do it. He's who sets up a lot of the cameras too. Mary Liz and Ryan are, half of Cosmic Perspective. You guys have seen their films on YouTube, I'm sure. This is the other half that you might not see as much, Mary Liz, and it's awesome because Mary Liz actually has done a ton of amazing interviews. You've interviewed. It's funny. My thing is Everyday Astronaut, yet I don't think I've ever interviewed a single astronaut.
We're swapped.
Yeah. Because yours is Cosmic Perspective, and I'm constantly like showing. I don't know. I'm showing things that go into the cosmos, so we're kind of backwards. But you've talked to several astronauts.
Many. Yeah,
more than one.
I've lost count. I'm obsessed with talking to people about the human experience of spaceflight because what is this all about? It isn't about the human experience. So yes, I've spoken to many and writing a book on it. We're doing a film on it. So yes, much to come soon on that.
Yes, that makes me very excited. I've been a big fan of your guys' work. We've been working together for almost over 2 years, actually, right?
Really? Oh, could be.
Or wait, no one was. Was it only a little over a year? In-flight abort was.
Wow, it's just the longest year in history, so it feels like it's been so many years. But yeah, in-flight.
Yeah, it was January 2020, so a little over a year.
Yeah.
Yeah.
Wow.
It's been right. I know it's. Oh God, that was a long year. Let's see. So this is. Oh, thank you from. So I remember, guys. I just want to answer a few questions since we're live. We might as well, say hi. Remember, ask good questions, and we'll put them on air. You don't have to be a member or a super chatter or anything. We'll put good questions up on air. And this just means a lot that the Kyob 3 said, love the channel progress. Seriously, it's great to see someone really reinvest their YouTube money into making their production even higher tier. That's the whole point here is, you guys are trusting to support what we do here. We're taking everything up a notch every time we possibly can. So our goal is not to provide you a good stream, but we want to provide you as good of a stream as SpaceX. And I know that's a very high bar, and they'll always have some camera options that we don't, but as far as quality, that is the bar we're trying to achieve. So that's up there. That's a high bar. That's very, very difficult. But yeah, so people are asking still, when is it launching? So notice the word scrubbed, just for those of you that don't know, it does mean, I learned the root of it. Actually, I found out kind of where the word scrubbed came from. This is really cool. The word scrubbed actually comes from like train departures and things like that when there was physically a time, like a departure written on a board. And if it, like, say the train didn't show up, they would physically scrub it off of the board, meaning like that is not going to depart. That is not happening.
I am so happy that you've given me this explanation because this has driven me crazy. I just wanted them to say delayed.
Right.
That makes perfect sense.
So so delay might infer that like it's delayed by a few minutes or, might still, a train, again, think about the train concept. Like if a train coming in to whatever bay, what do you call it? Station? There we go.
Bay.
Train comes
the
into
old
the train
train's
bay.
rolling into the bay.
The old train bay. If a train you with the salutes.
I don't know why. It's even backwards. It doesn't make any sense.
If the train is late to the station, right? Then it makes sense for you to say like delayed or late, and it still has the opportunity to do its thing, right? But if it's scrubbed and it's like it's not coming in today, like it's stuck at the other station or it rolled over on the tracks or whatever.
Oh
like,
gosh.
Yeah, hopefully not.
No.
Then you would scrub it from so that's what it means, scrubbed. Yeah.
So this train's not. It's not coming into the station today.
Glory. This train is not bound for glory. The bay, you mean? Or the bay. It's not coming into the bay at all. So, yeah. So let's see. Oh, this is a good question. Like I said, while we're at it, yes, we have everything set up. We might as well answer a few questions. This is a fun one. What is the second nose cone on the right? Hee hee hee. Despite all my rage, I'm still just a nose in a cage. That is a nose cone that they're likely going to be testing basically to destruction. So you see that nose cone in a cage. It has hydraulic rams, and it's going to be kind of squeezing down on the top of the nose cone, and it helps simulate some of the stresses and the aerodynamic pressure that the vehicle will someday experience as it gets to higher and higher velocities. Because so far, Starship has never exceeded like 100 miles an hour, 160 kilometers an hour, something like vertical. It actually goes really slow up, very slow. So the aerodynamic pressure is pretty low. Like it's not experiencing much stress. As opposed to when it goes to orbit, they'll be pushing it, just accelerating all the way through, and they'll reach this moment called maximum aerodynamic pressure, or max Q. And that's this moment where the air pressure, think about it, you're going up, you're also speeding up. So as you go up, the atmosphere is getting thinner, but you're speeding up, so the pressure, like imagine if you're speeding up in a car at sea level, obviously the faster you go, the more drag and the more aerodynamic pressure you feel on the front of the vehicle, the more wind resistance there is on your car, right? Now imagine if your car was going up, obviously it would start to feel less and less wind resistance or less and less pressure. So a rocket has this moment where it's this crossover, and it's not some set thing. It's not like at this altitude, it's based on the thickness of the density of the air and the velocity of the rocket. So different missions have different points of max Q, different actual pressures. It's where the vehicle's speeding up, so the pressure is getting greater, but it's also going up in altitude into thinner atmosphere. So eventually, because it's still going up, even though it's speeding up, the atmosphere is getting thinner and thinner, so that pressure actually drops lower and lower and lower. So this is something that they're going to test before they actually get this thing to orbit. They're going to be doing some pressure testing, basically some static pressure testing, and squeezing on that nose cone to make sure that it's good to go for those high dynamic pressure areas. So,
Tim, I've got a question that I'd like to ask here. It's actually from Astro SFS. And if we could get the graphics back on, Andrew, I don't know if that's too complicated, but everybody seems to really love the graphics. I'm in love with the graphics. Astro SFS asks, how does the rocket suck the fuel from the header tank to the engines? Like, how does it get there?
That's a great question. So normally, you know, a rocket, when it's sitting on the pad, the main tanks, you'll notice that there's some pipes and tubes going straight downward, right? And obviously when it's sitting on the pad, gravity is going to pull it down, and it's going to, you know, it's the more dense fuel is going to sit at the bottom of the tank. The less dense, either in some rockets, the parts that fill, you know, the voids, basically, because you're going to have empty spots in a fuel tank. Those voids are in most rockets filled with helium because it's very sparse, it's inert, it won't explode or anything if it gets ingested. Those pockets there, obviously the heavier liquid fuel will sit at the bottom, and so that's where the drain valves are. That's where the actual main downcomer, you might hear it called, or the actual the inlets into the turbo pumps at the bottom are, you know, gravity just kind of pulls it down while it's sitting on the pad and while it's accelerating, because while it's accelerating, it's actually more than gravity would normally be. You know, it has to have more thrust, more acceleration than gravity. So as soon as it leaves the pad, it's actually pushing down into those inlets even more, into those into that drain even more, because the rocket engines are actually pushing it up, and it's you know, essentially pushing the fuel down more into those openings. Now the header tanks, though, those are a little bit different. And the only reason Starship has these header tanks is because it's going to be falling on its side, right? It's going to be belly flopping out of the sky, using as much of its surface area as possible to slow down in the atmosphere on its way back down. Use as much of that atmosphere, use as much of the surface area as possible to scrub off velocity. Now, while it's in that horizontal position, don't forget, if you didn't have header tanks, the fuel would be sitting on the belly of the rocket where there aren't drains or there aren't, you know, pipes. It couldn't suck the fuel up, and especially at that point, the fuel would be so thin, right? It'd be this thin little line of fuel, like you'd be really likely to ingest air bubbles. So those header tanks are more or less full, and they also have some drains actually, or the pipes kind of come in at a 45-degree angle or so. The downcomers off those little tubes make it so that it can suck up the liquid fuel even at a belly flop angle, even at a sideways angle. So.
There's actually a follow-up question while we have the graphics up from Conaria X.
Cool.
X. Is it just dead space? Just to say it. Is it just dead space between the forward bulkhead and the header tank at the moment?
Yes, great question. Yes. So you can tell, yeah, exactly. That forward bulkhead, the spot there, above that is going to be the payload bay in the future. But right now, they don't have any payloads on this rocket. It's just testing certain portions of the landing profile, so they don't even worry. There's no payload. There's no reason to put anything up there. Anything you put up there is likely at this point to blow up, right? So obviously they aren't even bothering putting anything. But that is your payload section. That entire volume is almost 1,000 cubic meters. That's more volume than a 747. More pressurized payload volume than a Boeing 747. Think about the 12 people that are going to go around the moon for Dear Moon, that'd be like, or however many, say it's 10 or 12. That's like having 12 people on a 747 for a week. This
Awesome.
is no longer Apollo in a tiny little tent. This is like you can have an apartment in space going around the moon.
All right, Tim, you said it, so I'm going to have to highlight this comment right here from Tyler Locknett. Hi, Tim and crew. Have you heard anything back on your Dear Moon application, and have interviews started for step 4 of the application process?
You know, I don't actually know a lot about that, and if I did know something about that, I wouldn't be able to say anything either way, I don't think. So, yeah, I don't know if that's actually something. I don't have any information that I can share. So,
all right.
Yeah, I wish I did.
Well, we really hope that you get to have an apartment in space.
Well, that would be cool. That would be very cool. But yeah, I don't have, you know, you guys know me. I don't speculate on things. So that's not something that I have any information on, unfortunately. So yeah. Yeah, do we have any other cool, great? We have a lot of new members, and I do want to mention we put up some of our feeds early for our supporters, for those of you that support what we do on either YouTube memberships or Patreon. And if you guys want, a little heads up on getting our feeds as early as we set them up, even so, it's kind of a raw feed. Like, we don't want to produce, like, we're still setting stuff up. Every time we do this, we have to kind of do a lot of things here at the studio, less than we used to have to do. But our idea was, as soon as we get a feed going, we're going to put it up in our clean feed for our Patreon supporters and our YouTube members. It doesn't have me talking. It doesn't have me hosting. It's just, just a video feed. So we put up our Cactus Cam about an hour ago already. So if you guys want to get a nice clean feed with beautiful ambient audio, we put nice microphones out there at the pad and over the water. That's one of the things that we focus on a lot, is like high-end, good quality microphones. Mary Liz, you're an audio nerd. You know how much it matters.
It matters. Yes. We have a binaural mic out there right now just collecting all the ambient sound now that you say it. Can't wait to get that back. So many birds chirping and vents doing things.
Yeah, it is. I mean, it's beautiful audio. I mean, it's really cool. It makes a lot of sense to put not only good video. One of my really good friends, Jamie Higginbotham, always says that video is 90% audio.
Yeah.
And I think people don't understand how much that is true. So we try to do a really good job of piping in some good, beautiful ambient audio. So, yeah.
I have a question that I've been wondering about as well. This is actually not mine. This is from Jonathan Osborne. Jonathan asks, why do you think SN15 has a Starlink antenna included, just for some testing on Starlink, or is it helping transfer flight data? Is SpaceX already utilizing Starlink internally to do work?
That's a great question. So you might notice in some of the pictures, like people like Jack Beyer from NASA Spaceflight and some of the other photographers that have these insane, like, highly detailed photos. Find them on Twitter. Jack Beyer especially, and the other members of NASA Spaceflight do such a good job of chronicling with photographs a lot of the details of this vehicle. There's straight up pictures of they integrated a Starlink, a Dishy McFlat face receiver into the top side. So basically, when it's belly flopping, that receiver will be pointing up. They integrated it into serial number 15. Now, for now, I guarantee nothing of any critical importance is going through there. It likely is just another potential data transfer, a piggyback or having redundant. And I'm sure at this point they're probably just seeing, like, well, how does this actually work? What kind of data, what throughput can we get right now? How reliable can it be, et cetera, et cetera? What's it like under all of the stresses and conditions of a rocket launch? Can we get data from Starship using Starlink? The answer must be obviously something. So that's really fun to know. And I hope to hear more about that at some point. Is like, what is the long-term plans of Starlink integrating into Starship? That is really, really cool. So,
Tim, this is a beautiful comment. I hope you don't mind. I'm just kind of taking over here. Michael Carnifors says, repost from last time. You're out teching Cronkite. First of all, I just want to pause there. at CBS in the 60s and 70s, having a much higher quality TV studio covering space launches. How do you all in the team feel about that?
I mean, that is the goal. Like, we should be able to do better than they did in the 60s and 70s. No offense. I mean, like, you can do better with your phone these days, obviously. But as far as that impact of what, bringing that history to the general public, way back in the 60s and 70s, I mean, that is the biggest, in my opinion, the Apollo program is the biggest thing to ever happen to humans. Like, the biggest thing we've ever done, at least, as far as human achievement to date. And it definitely, like, maybe if we had some really cool footage of how the pyramids were built, or some really awesome footage of some early exploration or something, we might feel a little differently about some of that. And so maybe that's why, I mean, granted, going to the moon is still arguably the craziest thing humans have ever done. Like, we left our rock, like, we left the little tiny ball of goodness that is floating around there, and we, like, physically were bound to it. And then it's like, hey, actually, we built this, like, flamey stick thing, and we got on top of it, and we made it out into space. And we explored another rock that's really far away, like, hysterically far away, so ridiculously far away that it should be impossible. By really all accounts, it should basically just be impossible. And the fact that we had such a good chronicle of it, we had so much documentation, we had so much information, we had the ability to share this with the world. Imagine had that happened, imagine if we had developed rocket technology before we had developed video and broadcast technology. What would have happened if this was 40 years earlier? What would it look like? Those obviously a lot of technologies probably converge around the same point, so that's probably not a possibility. But I think this is kind of the point of this new program, this new era, is like, we have this technology, we have the ability to share and document this stuff at a quality that's never been capable, especially on our budget. Like a crew like us, a little ragtag rigmarole. You can buy really high quality stuff these days. We have a 12K camera.
Yeah, it's crazy.
You can buy a 12K, 80 megapixel video camera that can shoot 60 frames a second. Excuse me? 10 years ago, that would have been like impossible, right? So
yeah. And you know what else I think, though, is like, it's us and it's all the other independent photographers out there sharing things through their own feeds to their own communities. I don't feel like that existed in the Apollo era. And that's something that's really special right now. So I feel like this time is extra special for that reason. Like, we're seeing more behind the scenes, that stuff that you hope exists on a reel somewhere, but you're not sure. Like, every time we go out to the pad, there's somebody doing a behind the scenes filming, whoever's doing whatever. That just, I don't know about that in the Apollo era.
Right.
And then
right.
the other
it was like super top secret stuff, obviously, And
right.
The funny thing is, this should be.
Yes, it's crazy.
This is like the most advanced rocket technology in the world. By all accounts, it should be like super duper top secret. Yet it's like, we'll just roll our top secret, the most technological rocket engine in the world, out in the open, right down the road. It's just insane.
We're so lucky.
It's insane. I have a really good question here that I wanted to answer. It's a simple one. It's from Starship Super Heavy. Starship Super Heavy, interesting having you here, my rocket friend. What exactly is a turbo pump, and what does it do? So turbo, like as in a car, you might hear the word turbo. It comes from the word turbine, turbine, turbine. And it's basically, you can think of it as taking a high pressure flowing gas, spinning that turbine, and then you can do work with that spinning turbine. So what rockets do is, a rocket needs to pull a lot of fuel. They need to actually take the fuel that's at a relatively low pressure, like we'll say anywhere from 3 to 6 to 8 bar inside the rocket tanks. They need to take that low pressure and they need to feed it up into extremely high pressure. The Raptor can take it from 6 bars or 8 bar or whatever is inside the Starship, and they can pressurize the inside of the engine up to 300 bar. And they've even tested it beyond 300 bar. So they need to force that fuel inside the engine. So if you say you had a regular, like an electric pump, right? Like what the Electron uses, and you had to take all of that fuel and flow it through and increase the pressure that much, it would take an electric motor that's like the size of a house. It would be 100,000 horsepower required to run the pumps. Literally, like that's not some exaggeration. It's literally, or is it 10,000? That might have been an exaggeration. Is it 10,000 or 100,000? So yeah, it's a lot. Like it's a stupid amount of power required to spin those pumps. So what they thought, the clever rocket scientists, is like, hey, instead of trying to send an engine up there or something, what's more efficient than a rocket engine? Another rocket engine. So they literally basically have this mini rocket engine. It's either called a gas generator or it's called a pre-burner, depending on what happens after they use it. So the gas generator or the pre-burner, burns up a little bit of gas. It's basically a miniature rocket engine that just is shooting high pressure gas at the turbine, the turbo portion of the pump, the turbine portion, and then some of that exhaust is either expelled or pumped back into the rocket engine. So now you have high pressure, hot gas spinning the pumps. Then they can use that to actually spin the pumps. So you're basically using a rocket, like it's kind of like the exhibit or who is it? It's like, yo dog, I heard you like, TV, so we put a TV inside your TV or whatever. Like it's like, yo dog, we heard you like rocket engines, so we put a rocket engine in your rocket engine. Like that's what the turbine is, the part that receives the energy from the either gas generator or pre-burner. Watch my video about the Raptor engine. It's called "Is SpaceX's Raptor engine the king of rocket engines?" I go really deep into the cycle types. I go really deep into all of that stuff about kind of what the turbine is, and you can see good visuals that will help you understand all of that stuff. And hopefully that will help. Yeah. What else do we have?
I've got one here from David Hogan. He wants to know, will heat shield tiles cover the entire belly for a real mission?
Yes. So we're seeing already. So obviously they're increasing the number of tiles every time they're testing these things as they're learning. It's not only a test of the heat shield. Right now, there's not much heat or pressure, or any of that stuff on the tiles for these suborbital flights. But they're kind of testing the manufacturing process. They're testing, how do we stick these little tiles on this vehicle? How do we do it at scale? How do we do it cheap? And the we have to think about it as this vehicle goes higher and increases its velocity, all of a sudden those temperatures will increase, right? So it's going to be pretty substantial when they do have to come back in from orbit. The velocity and the heat will be extremely immense. So the entire, anything that's facing forward, which during reentry will be the whole belly of the rocket, will need to be completely covered in those heat shield tiles in order to not melt. Now the reason is, of course, stainless steel has a really high melting point. But as you're coming back in from reentry, your relationship to heat, your heat and velocity are not like linear. It's not like if you go twice as fast, you experience twice as much heat. And it's not squared. So if you go twice as fast, it's 4 times as much heat. It's actually cubed. So if you go twice as fast, the heat your vehicle experiences on reentry is almost 8 times as much. So that's a scary relationship between heat and velocity. So as this rocket starts doing more and more intense reentry, that's why the Falcon 9 booster, when it comes in from reentry, it's still only going a quarter of the orbital velocity of an upper stage. The booster is only going about 1/4 the speed. So the upper stage will experience almost 64 times more heat than the booster. So that's why this is the upper stage of Starship. It's going to be coming back in from orbit. So it could experience almost 64 times more heat than the booster of Starship, which will be the super heavy booster. So they really need that upper stage to have the entire heat shield capable of protecting and insulating and thermally protecting the stainless steel body of the rocket. So, yeah.
Just a quick thing. Someone in Discord actually just brought up the fact that RGV Aerial Photography says that they received the alert for tomorrow for May 5th from 12 to 8 p.m. So I know we don't know for sure when this is going to take place next, but I wanted to bring that up.
Yep. That's a great question. Yeah, so we're hopefully we can end this relatively soon, and Ryan can get back and he can get some sleep, and we can reset for tomorrow.
Do it all over again.
Do it all over again. Yeah, correct some mistakes like we always do. It's still an iterative process for us as well. We're living like SpaceX. We test, blah blah blah, try again.
That's right.
I did see someone, I don't remember if this was just in Discord or not. If it is, I would love to be able to put it up on screen. But I don't know. Oh, here it is. Actually, it's from Chip Garlic. Says, do they install the flight termination system on crewed rockets? So if there's people on board, do they have a flight termination system? Something capable of intentionally destroying the rocket? And the answer to that is yes. Because think about it. The rocket, if it goes off course, we can't risk populated areas. You can't have a rocket, basically a giant fueled up bomb heading towards, out of the Cape, heading towards Orlando or heading towards Titusville or Cape Canaveral. Like it needs to be able to, before it excludes, like as soon as it reaches that threshold of like, this is actually going off course, it needs to be terminated so it doesn't continue to accelerate and continue to change its direction, right? So as soon as you cut, terminate the engines or terminate the rocket, it will blow up. Most flight termination systems are a complete destruction where it lets go of everything, and what that does is they let it go so it would blow up in an area that's already cleared, right? So it's not like if it excludes this area that's clear, it'd already be going in a certain direction, then that debris field would be outside of the exclusion zone. What they do is the exclusion zone takes into account like the actual cone of where this thing needs to be going. So if it excludes and leaves that cone, that vector of direction and that heading, then and it gets terminated, the debris will still fall well within the debris field, well within the exclusion zone, so that there is no risk to personnel, right? Now, of course, most crewed rockets, because of that and the general danger of rockets, do have an abort system, right? They have a way to get off of the rocket. So if the flight termination system were utilized for any reason, if it would leave the direction, or if their engines shut down and started falling back to Earth or whatever, the crew capsule, the people will be able to get off of the rocket in that instance. Now, Russia doesn't tend to use flight termination systems, which is so bizarre. Like that Proton rocket that they had the inertial measurement units upside down or the gyroscopes upside down, and it was correcting opposite of what it needed to do and just totally went out of control. Like, I don't think I like that. I don't think I'd want to live anywhere near that because, we for sure, by the way, we for sure have a scrub today. It sounds like even the what's it called was taken down, the TFR, the temporary flight restriction. So we'll probably wrap it up here soon, but we just wanted to kind of go on air and give you guys an update. Is there any other really good questions we want to get to while we're live?
I love this one. I actually talk about this a lot, but this is a generous donation from Gabrielle Velasco, $15. Thank you so much. Asks, I have a theory that Elon's boring machines will fit inside a Starship with the goal of boring on the moon and on Mars. Have you seen any hints of this anywhere else?
I mean, what do you think, Mary Liz?
I absolutely think every single thing Elon does is for the one sole mission of his life, which is to make life multiplanetary and to go to Mars. So, yeah, I think that Tesla's Cybertrucks will be used on Mars. I think that boring machines will be used to dig out habitats on Mars. What do you think, Tim?
No, I'm exactly with you. I think, everything. Tesla, which even like electric motors and power, solar and battery energy. Obviously, SpaceX, duh. Even his brother, Kimball Musk, working on like solar farms or solar farming, or not solar, sorry, like urban farming, like basically taking like a shipping container and being able to produce your own food.
Yes.
From that has a lot to do with Mars and living on another world.
Starlink. That's going to be not only the internet system on Mars, but also the system that allows us to communicate back with Earth, those Starlinks around our planet.
Exactly. Yep. And pay for, a colony on Mars. Like that's Elon clearly knows that Starlink is a massive disruptor. Starlink, when it's available, should really shake up the telecom industry. If you have terrible internet, if you're one of those people like in the United States where you live in a major city and you only have one option for internet, and they know that, those internet providers know, like, well, good luck. You're stuck with us,
Yep.
What's that going to do? When all of a sudden it's like, okay, well, screw you guys. Actually, I'm just going to put this antenna on my roof, and I'm going to have gigabit internet for much more reliable, much cheaper, What's that going to do to the industry? And not only obviously in urban environments, but the underserved, or the people that do not have infrastructure now. This Starlink is going to be huge.
Yeah, that's the game changer, I think.
Yeah, that's how they fund a mission to Mars. That's how they fund the beginning of humans' next big adventure, which is actually becoming multiplanetary. If you think about it, back in the day, I wish the oil barons, had immediately reinvested in future transport,
Right.
and push like some big vision, like, hey, we are making, the Rockefellers, we are making, we're the richest people in the world, and our one vision, our one goal, that we have all this money, is we want to, something. Like, what's the big push? What is the big next thing? Not just like become richer, but like what is, let's make sure that everyone can transport around the world within 45 minutes or something, like that. There never was that big push. I think that's Yeah, for those of you tuning in, by the way, we're still seeing a lot of people. The title, notice it does say scrubbed. We do have up in the top right bar, scrubbed. We have the bottom update. Up next, nothing, because the rocket will not launch today. We decided just to go live and hang out for a little bit because we had everything set up. Like, it's stupid for us to spend quite literally all morning since 3:30, 4:30 a.m., most of us. Not me anymore. I decided if I'm going to be a good host, I have to have some sleep. Like, that's one of those just realizations of I wasn't a good host when I'm like on an hour of sleep or 2 hours of sleep. I'm just grouchy and can't think and can't answer questions. So yeah, selfishly, I'm now probably the most slept person.
You're the most slept person.
Slept human.
And yet, no. Here's a question for you, Tim, that I get a lot, actually. It is from Sebastian Saez. Why did SpaceX trash SN12, 13, and 14 instead of redesigning them and skipping to 15? Yeah,
that's a common question we get often, and there's a logical question of like, hey, 11 was last, why is 15 now? You need to remember that the pace of production was stupid fast. They got really ahead of themselves. Like, they can produce one of these Starship prototypes in like weeks now. 3 or 4 weeks, they can have a Starship prototype totally done. They aren't launching them quick enough right now to even test all the ones they have. But most importantly, they aren't even testing them often enough to be testing the things that go wrong and then make changes. So when they had launched SN8, they already had parts for 12, 13, and 14. Not the whole vehicle, but they had some parts. They had some rings. They might have had like one of the domes. Actually, Andrew, can we show the little skin on it too? Because what's funny is that one. There we go. So like things like we saw like the forward bulkhead of some of the vehicles. We might have seen the downcomer, the pipe that goes in between the methane header tank and the aft bulkhead, or the thrust puck. You know, we were just seeing parts. We were seeing certain rings, and they were labeled, but they were outdated. They were literally, by the time SN8 flew and they go, oh, this is not going to work quite like this, they stopped with all those parts. Then at that point, they were like, okay, well, why even bother testing these? We already know that this is antiquated. Let's move on to the next iteration. So this is stuff that likely happens all the time. Like this type of stuff happens probably all the time behind the scenes. We just don't see it, right? But because the factory is quite literally just like open air, and we have people like Boca Chica Mary and again Jack, people that are paying attention to where in RGV, all these people paying attention to every single little movement on site. We label and know which parts are which vehicles they're assigned to, which vehicles they're supposed to be on, right? So again, this likely would happen behind the scenes, and we wouldn't even know it. But because we were labeling and everything, we knew that there were parts for 12, 13, and 14. So now they basically, after SN8, they were like, you know what, screw 12, 13, and 14. Those are old. That's not even going to work. We're moving on to this newer, updated, tweaked design that is SN15. So, yeah, there we go.
An Explosive Joe 3000 asks...
What a great name.
I know. I'm like, wow, I am way too boring with using my actual name everywhere. Will SN15 light 1 or 2 engines on landing because of the 25% weight reduction from the 4mm to 3mm reduction?
Okay, so hold on. Don't forget the dry mass isn't entirely. I want to be able to. Sorry, I can't quite find where that is. I want to reread it just to make sure. So basically, will they? Okay, yeah. So light 1 or 2 engines on landing. So watch that video I have about the belly flop. We talk about the thrust options. You're absolutely right. But as they're reducing the dry mass of the skin, don't forget this is the tanks. They're working on shrinking them from 4mm down to 3. Now the skin of the rocket makes up a large amount of the rocket, of course, but it does not make up 100% of the weight of the rocket, right? There's still the weight of the engines. There's still the weight of the gimbals and avionics and the heat shield and the flaps and the flap actuators. All this hardware. I mean, we might be able to say the actual tanks make up 75% of the mass of the dry mass of the rocket. So then, if you reduce 75% of the dry mass of the rocket by 25%, you're still reducing it. Whatever. Making up whatever it is. 20% of the weight of the rocket will be lighter, the dry mass. But there are things they can have. Remember, they don't need to hover. They don't need to have a thrust to weight ratio of 1-to-1 to land. We know this from the Falcon 9. We know this is an option. What I think we'll see happen is they'll light 3 engines at the flip, when they first are doing the actual flip maneuver, as Elon has talked about. I think once they've flipped and everything is good to go, they'll go down to 2. I'm surprised they ran the flip all the way through with 3 last time, frankly. I'm surprised they didn't start on 3, and as soon as they know all 3 are running, instantly shut 1 down. I mean, but it looked nice. 10 looked good. When 10 did all 3 and 1, they shut 1 down after the flip, then they shut 2 down and went down to a single engine. And that's something Elon said they'll probably go down to 2 engines from then on. Now, that, of course, requires, if you're running on 2 engines, that right there requires that you didn't slow down too much, and your thrust to weight ratio is low enough to get you to the ground, because you can actually have too high of a thrust to weight ratio with 2 engines. So there's a chance that maybe what they'll do is they'll use 2 engines for as long as they can until they absolutely need to, and then they could always shut down to 1 more. It's safer once engines are running. They tend to be at operating, in an operational mode. They tend to be pretty happy. Your biggest risk of when running an engine is starting it up, right? You have all these transients, you have all these valves and everything that need to work in perfect timing. So getting an engine running is a lot harder than sustaining it. Once it's sustaining and running smoothly, it's it's easier. So the biggest risk is igniting the engines. So once the engines are running and they're down to 2, I see no problem if in their flight profile, if in their landing profile they need to go down to a single engine for the very last little bit. So we might see something like 3 engines down to 2, and then once it's doing that little, it might do a little dance, and at the very last minute they might shut down 1 more if they need to really slow down the landing and really have that fine control, because your ratio of your throttle range with a single engine is a lot higher than having 2 engines running. So that's a really, really good question. So, yeah.
Here's an important birthday announcement from Space Race Watcher Toxic. Here it comes.
Space Race Watcher Toxic.
Yes, happy birthday tomorrow. Thank you for the 20 Canadian, I assume that is.
Or Californian.
Oh, that would be crazy.
California seceded from the nation and started their own.
All right. It's opposite day. So it is their birthday tomorrow, and they hope it lands in one piece. And of course, we don't know for sure if we're launching tomorrow, but my gosh.
Yes.
I hope it lands.
Yes, I do too.
I think it will.
Yeah, I'm feeling... the good thing is, because they're taking a little bit more time with 15, to me that feels more conclusive. It feels more like they aren't just pushing through no matter what, right? I feel like 11, are you kidding me? That felt like that was pushed. They launched in the absolute fog. Turnaround time was nothing.
That was crazy.
That was probably the most go fever I've seen SpaceX. But that's okay with this stuff. It's not a big deal that 11 blew up. Like, it really isn't. I know we're so attached to these. We're more attached. I think the general public and us, tank watchers and fans of Starship are more attached to them than SpaceX are. They're just like, well, let's test it. What's the worst that could happen? And so it doesn't matter. But this one, it really does seem like they're starting to get to that point where, like, well, especially 11, again, was old hardware. 11 was basically, for more or less, a repeat of 8, 9, and 10. So they knew they weren't going to be testing the things that they even wanted to test at this point. Because now 15 has a new variant of Raptor. 15 has different raceways and slightly different plumbing, slightly different, all these little changes here and there. I'm sure they're just excited to get to 15 and see if their changes are working out. Yeah, so
I got to tell you, these birds in the background are absolutely incredible.
Yeah, isn't that fun?
So along that subject, Alex Churchill asks here, when or on which version of Starship might we see an updated landing leg design?
That's a very good question. I think for sure once they know, once it's solidified enough that they really want to actually recover and reuse these vehicles, then they'll need a good landing leg. At this point, they're kind of one and done so far, or one and not even done, like one and boom, So there's a chance that once they know, hey, this is actually we want to refly this thing. We're not just trying to test it. We want to recover and refly this. Then we'll see landing legs. Right now, they don't even care about that yet. Again, it's this whole different attitude. Yes, this vehicle is eventually hoping to be completely reusable, but they aren't even to that point yet. It's not even a possibility yet, right? It's still just they're still just trying to learn and test certain parts of this reusable system. Once they want it to be reusable, once they are to the point of this thing actually needs to start flying and we need to start, reusing it, we'll see things like better legs. But, they're hoping that SN20 is going to be the first one to go to orbit. So hopefully SN20, if it's going to orbit and they're hoping to reuse it, it should have some legit landing legs by then. Yeah.
I cannot wait. I can't believe we're going to be here for this. Anush Patel has just reminded us that it is Baby X's birthday today on May the 4th.
Yay, Anush. Yeah, May the 4th. First off, hi, Anush. And hi, our Discord channel. We had people asking, our Discord channel is for Patreon supporters. It is amazing. It's my favorite place to be on launch days, just to be able to hang. And not even launch day. For me, Patreon has been amazing when I'm scripting and writing videos because I have people to keep me sane. Because sometimes those are some rabbit holes that are just ridiculous, and I go way too deep, and I get in my own head. So having people be like, "No, Tim, here, let me help," and stuff like that, or I show them "Hey guys, I'm working on this. What do you think of this?" And they'll see these little clips, little snippets. So if you do want to join our Discord channel, and be up on our screens at all times, and we're reading everything from Discord as well. Just an awesome community. Consider becoming a Patreon supporter. Patreon.com/everydayastronaut, and you can join that way. So
And I actually need to point out, I know you said it earlier, but just to reiterate, people in Discord can now ask questions, and those questions can be pushed live.
You don't have to do anything special.
Yeah.
We're the YouTube mods and the Tomorrow mods are paying attention to what's happening on YouTube. They have a job, let me tell you, because they have to look at what's happening on YouTube. They have to look at what's happening in Discord, and also with like the super chats and stuff like that, and new members and things. And we're helping push everything to air. So the point of this, remember, again, to reiterate, the point of Everyday Astronaut is to bring space down to Earth for everyday people. And we want to answer your questions. Make this a place that's fun and friendly, where you can ask questions and not feel ashamed, because this stuff is intimidating. It's rocket science. Like, it's not, it's not easy stuff to learn. And sometimes when you're just getting into something, it's extremely like overwhelming. And what is happening? Where is this? Why? All of these great questions. And we want to be the place that you can feel okay to ask questions. You don't feel like you have to be this expert to keep up with the conversation. We want to help you just get excited about what's going on now, wherever you're at. And maybe some things might be over your head, and that's okay. The channel's full of resources for you. Stick around and watch a lot of my old videos. We break things down in extreme depth so that by the time you're watching the next launch, you have the knowledge base. Especially with Starship, I have 2 videos in particular that will really, 3 or 4 videos that will really, like 10 videos that will really, really help you understand what's going on launch day. But the ultimate one is the complete guide to Starship. And it compares the Starship versus Falcon 9. It runs through all of the systems of Starship, the header tanks, the engines, the fuel, the pace, everything about Starship. Watch that video before the next time this thing launches. Watch it today. So that in case it launches tomorrow, you have all that knowledge. We also released a video called Why Does Starship Belly Flop? Like, what's the point of the belly flop maneuver? And we break down the exact physics of that belly flop, of terminal velocity. We also go into engine throttling and thrust to weight ratios and all of these things, all of the decisions that make it so the belly flop is actually the only real way that the whole Starship system kind of makes sense at this point. So, yeah.
Here's one from Chad Winia, I believe. It's my birthday. This is Chad speaking. This isn't me.
Another birthday.
I know. It's incredible. And was hoping for a dual rocket day, but still get Tim and Starlink. Go Iowa.
Hey, Iowa. Okay, okay. Yeah, so Starlink, I don't know, is Starlink actually launching today? I haven't even seen any updates.
I think 3 p.m. 3:01 is
Central.
Let me
or
look.
so-ish.
Let me look into that.
Yeah,
to be
look
sure.
into that. And I'm not planning to stay live through Starlink. I wasn't really even planning to stream Starlink. I'd rather, again, just kind of work on things here in the studio, than just stream. No offense, another Starlink mission. They are actually becoming routine. That is hilarious. That a rocket launch of a Falcon 9 rocket, something 4 years ago, I was like crapping my pants every time it launched and just like, will it land? Now it's like, oh yeah, it's launching. It's the routineness of it is maybe the ultimate compliment. And the fact that we used to just we're at the edge of our seats, will it land, was the biggest question mark. And now it's like an absolute shock when it doesn't land. It's just so routine, so normal.
I love that. And in Discord, we've got folks saying, P. Thompson saying, still on track for launch at 3:01 p.m. Eastern time. That's the Starlink launch. And that's also the latest update from SpaceX on Twitter.
Yep. Okay, cool. Yeah, and that, for those of you that's basically 3 hours from right now. So we will not be covering that. I was not planning to cover that. We probably could if we wanted to, but I don't think we're going to. Let's see. This is what was I going to say? There was something that I saw go up really quick, and it was a good question, but I don't forget what it is now. What do you guys think? I feel like we should probably. Oh, here, I'll answer this just for fun, because I feel like there's a lot of people. Go SpaceX says, Tim, kindly make a long video how you learn rocket science by yourself. I don't think I'll make a video specifically about how you learn rocket science, because I'm not a rocket scientist. I don't know much about the actual rocket science. Like, that's not who I am. I am I'll call myself a spaceflight cheerleader, basically. And my job is to get excited about this stuff and to break what I know down, right? I am not an engineer. I'm not a scientist. I know a handful enough about the stuff to be dangerous. I think I've crossed the Dunning-Kruger curve to the point where I know how much I don't know. Like, I now realize, oh my God, I know nothing about like X, Y, and Z, right? The people that actually build these rockets, the people that actually fly them, they know, they have such specific fields on telemetry and on all of these sciences and mathematics that I can't even begin to wrap my head around, right? That's not who I am. Chemistry, don't even get me started because I don't even know how to say chemistry. Yeah, I think as far as learning rocket science, the best way, I think, if you want to learn basics about rockets and aerospace and rocket science in general, is definitely Kerbal Space Program. It's a game that you can get on the Steam store. You can get it also on like Xbox and console, PlayStation, Xbox. Kerbal Space Program, Kerbal, is honestly, in my opinion, it truly is the best way to learn rocket science. You learn about delta V, so the change of velocity. You learn about orbital mechanics. You learn about so much stuff just to play this game. And yes, it might just be a game, so you don't want to take it as like everything. And I did it in Kerbal, therefore it must work, because it still is it's a dumbed down, easy physics. But the physics are still, they apply to real life. So when you start learning about thrust to weight ratio, you start learning about aerodynamic drag or reentry heating, all of these things, I really genuinely believe that you can learn an awful lot by playing Kerbal Space Program. So, yeah. What was that?
Speaking of Kerbal,
yeah.
isn't there something coming up?
Oh, there's something coming up, Tim, that you have to announce.
Hype.
Oh. What should I do? Should I do a drum roll? Is that my job now?
I think
Can you hear it? Is it good?
Yeah, we can definitely hear it. Sounds great. Sounds just like a snare drum. As this channel is approaching closer and closer to that 1 million mark, I will be doing a live stream on near the 1 million. We'll do a 1 million subscriber episode at some point. A long live stream. It's going to be a very long live stream. And I decided so check out Twitter. I hope I made that thing long enough. I bet I only made it 24 hours like a Dumbo. But get on Twitter right now. Find me on Twitter, Everyday Astronaut, or Everyday Astronaut, actually, because Everyday Astronaut is too long. And I'm gonna do some big Kerbal challenge, something very difficult. It's going to be a fundraiser for the Challenger Center. So we're going to raise money through YouTube. So YouTube, we had this problem last time. I kind of helped a fundraiser with Rocket Lab. Was we didn't have time to set up the fundraiser for a nonprofit through YouTube. So YouTube is still taking the normal 30% cut, that they would normally do for Super Chat. So I decided the responsible thing to do would be to cover that. So that's not ideal to have to pay, YouTube 30% of everything, right? So if you do the fundraising option through YouTube, it all goes to the charity of your choice. So we will be doing a fundraiser for the Challenger Center, which is after, it's a nonprofit after the Challenger disaster, for the crew of the Challenger and Christina McAuliffe specifically. And it's all about getting kids excited about spaceflight, getting them out to science centers, getting them out to field trips and doing all this stuff. So we're going to be raising money for them. They don't even know this yet, by the way. We just integrated it all through YouTube. So hopefully they just get a big fat check after like a massive live stream at some point in the near future. And yeah, it's gonna be awesome. We're gonna raise money for the Challenger Center, and we're gonna do some kind of Kerbal challenge. We don't know exactly what, but I want something that I've never done before on Kerbal, and I want it to be really hard, like something that should take, if it's something I do in an hour, done. I want it to be like, I don't know if I can do this. We need to find a hard challenge, because then the punishment is if I don't complete the challenge within one stream's worth. If I take the stream down for any reason without completing the challenge, I have to put on the spacesuit, which you guys know is maybe the ultimate punishment for me. That's the worst. I never want to touch that thing again. So
what happened to you, Tim?
I got burnt out. That thing is just the worst. It's just so uncomfortable and stinky and sweaty and so bad. I don't want it. I don't want to put it on. So that would be the punishment. If I don't complete the Kerbal challenge, I will put the spacesuit on, because people ask me where the spacesuit is, and I'm like, I'm not touching that thing.
I think it's a good time to ask for ideas for that challenge.
Yeah, let me know. Especially get on Twitter, and let's come up with a fun Kerbal. So if you're familiar with Kerbal Space Program, the planets are slightly different. There's Duna, which is kind of like Mars. There's Eve, which is kind of like Venus. Let's think of something fun. I love Eve. Eve is like one of the most challenging planets. I love Eve challenges, and I it's hard for me to walk away from an Eve challenge because it's my favorite. So I'll be heavily biased towards a good Eve challenge. I still don't think I've ever done a fully reusable Eve mission before. That is a extremely high bar. So that might be the one that I go for because that has a very high chance of failure. Like, if I do it, I will be so happy, not just because I don't have to wear the spacesuit, but just because it's something that I've tried for years. So, yeah. So there you go. Not for lack of trying, Casper, exactly. Like, every time we do a Patreon live stream and I play Kerbal, it's like, guys, what should I do? And they come with all these ideas. And I'm like, I just want to try and get off of Eve on a reusable vehicle. And I never can. So it would definitely be, like, the challenge. Yeah. So there we go. One more from M Tennis. Could you reintroduce your female co-host? Yes. Sorry, we will get a lower thirds for her next time. This is Mary Liz Bender.
Hello.
She is our Capcom. She is half of Cosmic Perspective.
That's right.
The YouTube channel. Tell everyone what you guys do.
Yeah, so we make films about this new beautiful space age we live in. And right now we live here, obviously, at the site of Starship. So we're making a lot of beautiful Starship films. So if you go to youtube.com/Cosmic Perspective, you can learn more about what we're doing here.
Yeah. You guys know. So, I hope that by now you've seen Cosmic Perspective's films. We've been collaborating for over a year.
Yep.
What we do is our theory is like more is better.
Yes.
So we just share everything. We share equipment, and what this production takes is a team of people. My goal is to be able to I would like to make pixels. I was a photographer. I loved taking slow-mo video. Ryan and I shared that passion. It's funny. Ryan and I both started he'd started doing slow-mo 5 years ago, I think.
Yep.
Something very, very long time ago. He was working on incredible slow-mo footage, and then he was doing it with this really weird camera that had a really short little window of recording. And I remember, I really wanted to do it, but I'm like, that just scares me. I started using this camera called a Z-Cam. I show up to a launch, and Ryan has a Z-Cam. We both got it at the same time, and we both started just nerding out over the same camera, learning how to trigger them, learning how to do all these awesome things. Yeah, here's what a Z-Cam looks like. They're small. They're small little cameras. They can shoot 4K, 120 frames a second. That's the majority of our cameras, are Z-Cams or Blackmagic cameras.
Yeah.
So yeah, our theory is more is better, and it doesn't really matter whose camera gear is what. We just want to make awesome footage. It's kind of since we have those cameras out there and we need to learn how to trigger them, learn how to do all these things, we might as well make a live stream out of it. It's kind of this dual thing. It's there's so much cross-pollination between both of our goals. So it's I'm going to try and bring it live, and then they will break it down into these incredibly gorgeous, artistic films. You need to see there's two recent ones, or there's the Valhalla one, which is run us through your recent ones with Starship, because those are absolutely stunning.
Yeah, well, thank you, first of all. That's really generous and kind of you. It all started with SN8 for us. We came here in December to film that, and that's my favorite film that we've produced so far. I feel like we really found our voice there. I was just so happy to interview Rachel and Jean from Espadre, fell absolutely in love with them, and just loved learning from the local community what it was like to see the first mounds of dirt piled here, and then to document it 24/7 up to today. So that little mini film really kicked off kind of a new tone for us. And since then, we've had a little film that comes out after every single Starship launch, and Rudd, unfortunately, can't...
Rapid unscheduled disassembly.
Yes, and I really can't wait. I mean, we've got some beautiful slow-mo Michael Bay style explosions, I think it's SN10, where the exposure on that fireball is gorgeous. But Valhalla is one of our recent releases that kind of goes through SN8 to SN11, a little tribute to all of the starships that came before. But I can't wait until this thing lands and we get to have a triumphant song at the end. We're all screaming with joy. soon.
Yeah, I feel it coming for sure. I have such a good question that I need to make a video about this, because this is one of those like physics questions that is such a good question. I just have to get it on air right now. Scott Jensen, why does an orbital vehicle have to come in so hot? Is there no possible way to skim the upper atmosphere until it slow down? No, because as soon as you touch the atmosphere and start to slow down, you're becoming suborbital, and you're going to fall into the atmosphere. Then your orbit. So the way that orbits work, if you slow down, say like pretend you have the circle and your spacecraft is here. If you slow your spacecraft down, your orbit on the other side of the planet, or the thing you're orbiting, will go in. It will shrink. Your like the opposite side of where you are will go down, will go towards the planet. If you speed up from that point, if you go prograde, your orbit will increase. So if you're orbiting the Earth and you begin to slow down for any reason, your orbit begins to shrink, which then, imagine, now gets you deeper into the atmosphere. Oh, now you're deeper in the atmosphere. All of a sudden, you're in thicker atmosphere. It's slowing you down more. Oh, now, like, it just compounds to the point where all of a sudden you are completely on a suborbital trajectory. So there's no way, like, it's kind of like, imagine if you're on, let's pretend you're on like a water ski and you're out water skiing. If you let go of the rope and you start slowing down, at some point you don't have enough lift and you will go into the water, right? Like, you need to go fast enough to stay on top of the water, right? Obviously these physics are completely different, but it's kind of the same concept. Like, there's a certain threshold where you go too slow and you're not, you're out, all of a sudden you're getting into the part that's going to slow you down more. Like your skis all of a sudden will get underwater and then you're like totally in the water, right? Like, you're no longer on top of the water. You're succumbed by the water, and the drag and everything is taking you down, and you're no longer on top of it. It's kind of the same type of thing with the atmosphere. If you're skimming the atmosphere and you start to slow down, all of a sudden your orbit, you won't make it to the other side of the planet because you've slowed down so much that you're now like bound and destined to re-enter the atmosphere. So then people are like, well, why don't they just slow all the way down before they re-enter? Well, think about how big of a rocket it took to get them up to that point, right? It took the entire Falcon 9 to get it there. So to get it, if you had to slow it down in space and slow it back down all the way to like, suborbital or back to, zero velocity and then fall back in, you'd have to have another Falcon 9 up there parked revert, like firing retrograde to slow you all the way back down, basically, if you're, ignoring some other physics, obviously. But so the best thing to do is use the atmosphere to your advantage. But you have to do it carefully, because the atmosphere is a dangerous little beast. It's tantalizing, and it can do good, but it can also, blow you up. So, yeah. Let's see. This is from Martin Poyer. Hey, hi, Mary. Close. I like the effort on Mary Liz. It is basically one smashed word of two names, right?
That's right. Yeah, Mary Elizabeth all smushed together. Mary Liz.
A smush mosh.
Smush mosh smush.
Yeah, Mary Liz and Tim. How are they going to lift the high tower? So the actual orbital launch tower that we see. Do we have a shot of the orbital launch tower? Kind of.
A little bit, yeah. Coming up.
We still have one. On the right next to Hopper, the shiny metal R2D2 guy, you can see part of the orbital launch tower being processed right now, like coming to life. And what they're doing is they originally were kind of stacking them out on the pad, right? They're taking these beams out to the pad and stacking it, but the pad is being closed every time they try and do a launch or anytime they test, so the crew can't build the tower. So what they're starting to do, we're seeing them out at the production site building the tower off site. Then they'll roll it out there onto the pad and they'll stack it with a gigantic crane.
And that's going up pretty fast, so I'm excited because I think that, I think people are kind of getting used to this being at this stage, and they're kind of, they're like, oh, okay, I guess they've paused progress. No, they have been making progress on another area, and that's going to get rolled down and plopped on, and this will be finished before you know it.
Yes, and actually, I don't know is my screen working, Andrew, that I can share my screen or not? Okay, because I want to, not youtube.com.
Oh, Lord.
I had someone say this the other day. I saw it like on a tweet or something, or on Reddit or something. And they said just watch the SN15, the footage from, not SN15, SN5. I just want to pull this up and watch what this place looked like not even a year ago.
Wow.
This was this was July, wasn't it? Look at how empty it looks.
Wow.
Sorry, you might hear a little bit from my speakers. We're not cranking you guys the audio. But think about that. Like this was like a bare bones. I remember that it like destroyed part of the launch pad. The site was bare bones, and to see it now already is like, what has happened in just 9 or 8 months or whatever?
Yeah.
Oh, it's just insane.
Every day more. I know we talked about it on the last live stream. And you know, just going down there this morning, I was like, oh, wow, SN16 is fully stacked. And there were like 3 people welding the launch mount table. And, you know, it's supposedly the day of launch. And they're just busy working on everything.
Yeah. It's just so crazy how different the site looks from just such a short time ago. I mean, here's a shot. I mean, like, there's no fence. There's nothing. Oh, then they end it. Wah, wah. Look at this, smart.
Now there's a fence.
YouTube autoplay showing just garbage. Let's see here. It's nuts how quickly the pad and how quickly the infrastructure is being developed out there. Mm-hmm. Let's see. This is a great question from Jacob Miller. May the 4th be with you. When is your big Starship model coming? So I got to show you guys this. This is like next level from Starship 3D. A friend of the show is going to be sending us perhaps the coolest thing in the world, maybe? Wow. I don't know. Look at this. I want to make it real big for you, Andrew. So this is from Starship 3D on Twitter at @DStarship3. This is my SN11. I like that I'm getting SN11, the vehicle that haunted us the most. This is somewhat intentional. Like, he could have made any prototype. I wanted SN11 just to remember what it's like to, because we didn't get to see it, really. We didn't get to see anything from SN11. SN11 was a jerk, so it's going to live with us for the rest of the studio's life. But these are super cool because you can actually take it apart, and I can show you guys some of the inside of Starship thanks to this incredible 3D model. I mean, look at the detail in that thing. It's just absolutely ridiculous. I can't wait. These are big, too. Like, this is like the size of the sign or something. Like, it is a full meter tall or something. Just absolutely absurd. So I should be getting that, I think, next week or so. I have to, talk to him about it a little bit more about where to ship it because I wasn't quite sure where we would be. So it's going to be awesome. I can't wait to be the owner of the world's most incredible 3D Starship 3D printed model. It's going to be incredible. So
I've got one here from Daily Random Jokes, which I need to look into. How are Starship's flaps powered, Tim?
Ooh, that's a great... I mean, so basically Starship's flaps are powered quite literally by Tesla motors. Like, they literally gear Tesla motors. You know, Tesla motors have a lot of torque. They're readily available because of Elon Musk owning Tesla, of course, and SpaceX. There's a lot of cross-pollination there as well. So the motors from like I believe either a Performance Model 3 or maybe even a Performance Model S at this point are what provide enough torque to be able to move those flaps. And those flaps move fast. They can go from like fully open to fully closed way faster than I thought. Like, it's several degrees a second. I mean, it looks like it's like 15 or 20 degrees a second. Like, it's a quick range of motion. There's an insane amount of torque that needs to be put on those flaps in order to actuate them so quickly. And they use Tesla motors, and they were using Tesla batteries, but I think with these newer prototypes, I'm not sure if they might be moving beyond that to their own thing. So
Tim, someone has asked, and I'm trying to find it here, but I saw it as I was scrolling past. Do we know the reason for the scrub? I don't think we do.
We don't. We know it has been scrubbed because of a lot of reasons. The TFR was canceled, the temporary flight restriction. Mary, Boca Chica gal, she was not told to evacuate anymore. The launch has been scrubbed. The weather might be part of it, even though it's quite nice. It's a lot nicer looking to me, like the layman person, compared to SN11.
Well, everything looks better than SN11.
I mean, you might as well have a blanket over your head and be like, yeah, it looks great when it compares to SN11. But, we don't actually know. There could be stuff with the vehicle, could be stuff with weather, it could be stuff we don't know. But it is scrubbed,
Mm-hmm.
I probably want to get us off air here so we can start cleaning up and get everyone fed here on site in a little bit. But again, I'm sorry if we didn't quite get to all your comments and all your your YouTube members and everything. I really, really appreciate all the support and the fact that you guys want to just kind of hang out and talk rockets. It's awesome. I really appreciate you guys just coming in here, saying hi, hanging out with us, even though there's nothing going on. You clicked on a stream that said Scrubbed. Like, that is awesome. I mean, how fun is it that you guys want to just come hang out and answer some questions? But I think it is taco time.
Oh, I'm sorry. I am apparently very emotional about this.
That's your emotions. Your emotions come out in song. We all do know this. I think we're gonna get off air here for you guys so that we can get back to our grind here and hope that tomorrow is the opportunity we're looking for. Andrew, when do you leave, by the way?
Oh gosh.
Not anymore.
Oh, good.
Andrew's response was not anymore, which is the best news of ever.
I don't know what we do without Andrew.
Yeah, we need to introduce Andrew. I feel like Andrew, say hi. Say hi in the normal camera.
Hello.
So that is Andrew Taylor. He's been behind the scenes on everything in the last year, basically. Andrew and I started working on doing video production together just for the actual scripted videos. Andrew he was very not busy because he normally was working for ESPN and other TV studios, running the actual live productions, which is why you could tell we're going with live production land here, because we've got Andrew behind the scenes. But he also, so at the time during most of 2020, he was helping me produce scripted videos. Then he started getting busy right when we started ramping this up. But, we're lucky to have him now on site because he is beyond necessary. I don't know what we're going to do the day there's a full-blown conflict, because he is running the show, and I still am learning as much as I can about live production. It's something I've never dabbled with, and it's insane. But we're working on, as you can tell, hopefully you guys are seeing the fruits of the labor, that we're hopefully getting this to be a high-quality stream with high-quality audio, high-quality video, with graphic overlays, and just some fun stuff. People do ask, why Mary Liz is looking that way and why there's like Timception a little bit, Tim on Tim. At least it's in sync now. Look at that. That's pretty neat. But for now, like, we're still trying to figure out the studio. We have a pretty limited space here. But I like that that's kind of behind the scenes. I know it's kind of weird with me in the background of the same shot and we're not looking at each other, but we're all looking at the screens. Like, we're in our own mission control. We're looking at a whole display, the whole wall of screens. I should just turn this camera around quick. Spin her around. So this is my view. See, it's of mission control, basically.
Oh,
so
that's weird.
I
Hello.
know. So I want to be looking at that. I need to be facing this way. The layout of the room just makes sense. Mary Liz has her own little Capcom table. Andrew's, of course, running the show with a switcher. So it kind of has to be this way. I don't really, and of course, out this window is where Starship is. Like, we are within line of Starship. We are 8 kilometers, 5 miles away from Starship. And it's a straight line of sight. We put our telescope and our tracking cameras out there. Not today yet because, we don't need to, obviously. But yeah, that's why Mary Liz is facing that way. I know it's a little bit unusual, but it's as if, NASA would be doing the same thing. They don't have the Capcom facing the room. They're still facing mission control. They're still facing the information and the data. So I think it makes sense for us. It might not make as much sense for you guys, but, get used to it. And again, the point of all of this, beyond, capturing and sharing history, is to help bring you guys along for that. That is the point of Everyday Astronaut and the point of Everyday Astronaut live streams, that we want to help make clear, is we want to bring you guys, make it feel like you are here with us. That's why we are on air. That's why we host on air. So you can live through our experiences, live through our emotions, the pros and the cons, the yays and the disappointments of scrubs, the disappointments of RUDs, the explosions, or the excitement occasionally of explosions as well, of course. But you can live through it with us. That's what we're trying to bring you guys, is bring you along for the ride, make you feel like you're here with us. And we're constantly tweaking, and hopefully you're starting to see the fruits of the labor, that we are actually making a very high-end live stream. And it wouldn't be possible at all without all of your wonderful support, all of you guys tuning in, hanging out, all your subscribers. So if you want to help us do what we do here at the show, consider becoming a Patreon supporter by going to patreon.com/everydayastronaut. Of course, there you'll gain access to not only our awesome Discord channel, but also our live feeds as soon as we get them on air, we just kind of put them up. You know, they'll be rough. You might see some blackout periods and color changing and all these weird things as we're setting it up. Whatever, it's just kind of raw. That is also an option if you are a Patreon supporter of Cosmic Perspective as well. You will also get that link. So if you want to just directly support their work, which I encourage, at this point we have plenty of patrons, and I don't want to reach 10,000 patrons because I don't want to buy a ticket to space. So
oh, come on, come on, take us with you. You're our only hope. No, but may I just say thank you, Tim, for letting us do that, and shout out to our Discord and Cosmic Perspective. I love you guys so much. Thank you.
See, we're trying to, team space, baby. Like,
yeah.
How do we work together? There's so much cross pollination just in general. Like, there's a lot of overlap in a lot of what people are trying to do. Like, can you improve? Can our live stream be better if if we're working together? Can your work be better if we're working together? The answer is clearly yes.
Always.
Like 100%. So it makes a ton of sense for us, and we just absolutely love it. And it's all possible because of you guys. You guys make this all possible. I like to just reinvest everything we make here on air and just crank it back out into the system and see how we do. And hopefully by the time this thing goes orbital, we will be putting on the most ridiculous show in the world.
Yes.
And we're going to be able to go on live, before SpaceX does, and provide you views and opportunities that won't be available from the official streams, So, yeah. All right, my friends. Should that be it? Is that
Let's do this again.
Yeah.
Really, really soon.
Hopefully we do it tomorrow.
Yeah.
I mean, I do hope it's tomorrow. I have to be somewhere on Saturday, and so
no.
Yeah. I mean, I'll fly, but at worst case scenario, and it's Mother's Day Sunday. I was hoping to be home this weekend.
Yes.
Hi, Mom.
Hi, Mom.
I hope I can see you on Mother's Day. If not, I'll see you like soon. It's not like, yeah. That's always weird with holidays. It's like, I want to like, can we just do it next week? Is it the same thing? If it's not the day that they claimed is like the day to celebrate your mother, shouldn't that be every day?
Yeah, it should.
Shouldn't you just love your mother every day? Okay. Anyway. All right. Thank you guys so much for tuning in. Hopefully we'll see you tomorrow. We'll keep up to date on Twitter. Follow all of the things in life, and we will see you guys as soon as there's another opportunity for Starship to launch. Thank you for watching a scrubbed launch. I appreciate all your questions. That's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. Goodbye, everybody.
Bye.